You ship a support bot. A customer asks for a refund. The assistant replies, "I have processed your refund," but no refund happened. Why? The large language model, or LLM, invented an action in plain English, and your app treated the answer like reality. The database never changed. The payment system never heard about it. Now support has a mess. This is the first lesson of tool calling. Text about doing something is not doing something. We need a clean boundary between asking for work and executing work. The beginner version is usually, "Here is a list of functions. If you need one, use it." Then the model writes a sentence like, "I called get order status," or it formats something that looks like code. That is not reliable automation. Models predict tokens. They can describe an action, misunderstand a function name, omit a required argument, or claim success because the wording sounds helpful. Worse, if your code scrapes the assistant text and runs whatever it finds, you have built a fragile parser around a creative writer. Tool calling exists to replace vibes with a protocol. The model can request a specific function call, and your software decides what happens next. Here is the whole concept. A tool call is just structured output with a function name and arguments. The model does not open files, call APIs, query databases, send emails, or charge credit cards by itself. It returns a machine-readable request, usually shaped like tool name, argument object, and a call identifier. Your application receives that request, validates it, dispatches it to code you wrote or approved, captures the result, and sends that result back to the model as more context. The final answer is produced after the model has seen the tool result. Once you see this round trip, agents stop looking magical and start looking like ordinary engineering with a probabilistic planner in the middle. The build has 5 moves. First, write a normal function, like get order status, order ID, string returning a dictionary. Second, describe that function to the model with a schema: name, description, parameters, required fields, and types. Third, send the user message plus the tool descriptions to the model. Fourth, inspect the model response. If it contains a tool call, parse the JavaScript object notation, validate the arguments, check the function name against a whitelist, then call your function. Fifth, append a tool result message, link to the call identifier, and call the model again. Today we do exactly 1 round trip by hand. The automatic loop comes later in Tier 3. Imagine a local help desk bot. The user asks, "Where is order A100? Your tool schema says there is a function named getOrderStatus with 1 required string argument, order ID. The model should not answer from memory because it doesn't know your order table. It should return a tool call, name getOrderStatus, arguments order ID equals A100. Your code looks up A100 in a local dictionary and returns packed, estimated delivery Friday. You send that result back as the tool response. Now the model can answer, order A100 is packed and estimated to arrive Friday. Notice the important detail. The model never touched the dictionary. Tool calling is cleaner, but it is not magic. The model can still request a tool that does not exist. It can pass a string where you expected a number. It can omit required fields. It can call the right function for the wrong reason. Your code must reject unknown names, validate arguments, handle exceptions, and return clear errors. Be extra careful with side effects. Sending email, deleting data, placing orders, or moving money should require tighter permission checks than reading a local record. Also, tool output is just context when it returns to the model. Treat it as data, not instructions. Most tutorials skip this. You own the execution layer. Tool calling is one organ inside an agent, not the whole creature. The agent still needs a goal, a role, tools, permissions, state, a termination rule, and a harness that decides when to call the model again. Today we are only learning the handoff: request, execute, return. Later, the harness will repeat that cycle until the task is done or a stop condition fires. That is where agents become useful, and also where they fail loudly if you skip basics. Model selection matters too. Use the newest capable model in your stack that reliably follows schemas, because weaker models often produce more malformed calls and need more guardrails. Try this safely on your own machine. Create a Python file with a local dictionary of 3 items, like order IDs or book IDs. Write one function, getItem item ID, that returns a dictionary or an error. Define one tool schema for that function. Ask the model a question that requires the lookup. When the model returns a tool call, do not build a loop yet. Print the raw response, parse the arguments, run the function, append the tool result, then call the model once more for the final answer. No third-party systems, no real customer data, no side effects. The goal is to see the wire protocol with your own eyes. Recap in 3 beats. 1. A tool call is structured output, not execution. The model asks for a function by name with arguments. 2. Your code validates that request and runs only the functions you wired up. The model cannot touch anything you did not expose. 3. The result goes back as context, and the model uses it to produce the next answer. That boundary is power and responsibility. In the next episodes, we will make the boundaries stricter with schemas, errors, permissions, and eventually the agent loop. New Agent Foundations episode daily. The paid libraries at aislabs.ai go deeper with production patterns and reusable code.